Okay, and in previous video, we showed how to construct the single neural perceptron and how to train the synaptic weight. And in this video, I'd like to show you how to validate your result. So let's start to coding. This part is for testing purpose. First of all, let's shuffle the data one more time. We do this guy. Do the shuffle. But here we know that is the testing data instead of training data. Test. Okay, now let's check all the output for I equal to 1 to 2500. And then let's get in the first input. The input first one will equal to, input will be a vector. The first one is 1, and then will be the data from the shelved test. Here we know for this guy, it's a 3 by 2500 matrix. The first two are their coordination, and the last one is their label. So what we choose the first and the second one. Now we have the input, and then we get in the input multiply with the weight. Let's give two. Let's try two things. The v initial. In the v initial, we use in the initial weight. It's the initial weight int, and then do the transpose, and then multiply with input data. Input data. And another one is using the well-trained weight, because the v final using the final weight, just the weight. And then we have two output. One is using the initial weight, another one using the final updated weight, the well-trained weight. So we have the output using initial weight, we call it int, initial weight. That is the II equal to my activation function. And then input is the v initial. And we have the final or the optimal output, OPT. That is the II using activation function using the final v. And then we can get their total like this. And now let's plot the output. Output. What we do is we still using the dot plot, the star plot, using the red color and the blue stars. For I equal to 1 to 2500, and then x will equal to your input. That's 2 to 3, and then is the II. The first one is equal to 1. The input 1 is equal to 1. So let's have to use the second and the third one. And y will equal to output. Let's give 2 of them. Output. Try the initial first. T. I. And then let's plot them. So if y equal to 1, we're using red color. We plot x1 and x2, and we're using the red star. And the marker size give it like a 9, relatively large. Else, we plot using the blue stars. And then end and hold on it. Now let's look at if we using the initial weight, just random choosing the weight, what the result looks like. This is using the initial weight. You can see this part supposed to have red color, but because the weight is not optimal, so this misclassified as the blue color. And for this part, it's supposed to be blue color, but because the weight is not perfect, let's give you red color. Okay, let's give another set using the final weight to see what the result looks like. Here we're using the final, the optimal, the OPT. So OPT, and we give a new figure. Let's see the results. So this is the result we are looking forward. So this is the using the final weight. I can put these two side by side. So the left one is from the initial weight. It's random choosing the weight, and the right one using the final updated weight. So we can see the final weight can give us the good result. That's what we are looking for. And the left one, obvious the weight is not good. We have a lot of errors. So I hope this code can help you to understand how can we using the steepest descent method to update the synaptic weight. Okay, thank you for watching this video.